All right. Welcome back to day 26 now already, and you know it's almost going to be a month of starting data structures and algorithm, and it has been you know a smooth sail so far, at least from a consistency point of view. All right. So I'm just going to start with the optimization of this maximum pair XOR question that I started yesterday. Um, this question, I I previously solved this, but it wasn't. This was the first answer I submitted on the 15th. Yeah, so I mean this worked, but as you can see, sorry, um, let me just shift this a little. Okay, all right. I don't know why. Okay, so you can see this is not the best solution. So I thought about optimizing this, and my method yesterday didn't quite work, but I realized what I was doing wrong. It was just a um minor I would say oversight. Um, it's just an oversight in that solution that I was trying to implement. So I'll just come back here again. I'm just going to continue with this way of doing it. This is actually um, the right way, but I was, you know, my second loop, my nested loop was, the issue I had. So let me come here. I'll go to, how do I go back from this code? Okay. All right, so here's the adjustment I made yesterday. But when you look at this, you know what? Let me just shift this to the. I'll just shift it. Let me shift it up. It's easier to scroll up than down. Okay. So I'll just copy. Uh. You know. Let's say 1, 2, 3, 4, 5. Yeah. And what this question is asking us to do is to find the maximum XOR between two strong pairs, right? And there were some conditions for us to find, if a pair is actually strong or not, right? So a pair will be strong if the absolute value of their difference is less or equal to the minimum between those two pairs, right? Or between those two items that form a pair. So what do I mean by that? Let me just come here and take this my stylus. So I'll do this, right? I can form a pair by repeating the same number twice, or just by repeating the same integer, or the integer and any other value in the array, right? So to do that, I'll first of all create a loop, a first loop, and let me say an outer loop, right? That point at the character, I mean the integer we want to use to form a pair. It Before I even do that, let's just do it, in a very straight, without coding way. So my first pair would have been, 1 and 1, right? And then a second pair will be 1 and 2, and so on, all the way to 5. Another pair will be, because we already did 1 and 1, we want to start from 2 and 2. So we'll have 2 and 2, right? 3, 2 and 3, 2 and 3, and so on. This way we would have m- created a pair between the integer, the starting integer, and every other character, and every other integer on the in the array, and the integer itself, right? It would have repeated twice, which is here, right? It would have repeated. I mean, repeating is just okay. Repeated twice is actually correct. So I would have repeated that integer. Let me see. Oh, this internet is just bad. What do I do? Save me, Lord. So now, how do we create pairs like this? Now, when you observe this, right, you can see that we started from the first integer, right? We repeated it, right, and then we started moving, towards the rest of the integers in the array, right? So to create something like this, we need to start with a for loop, right? An upper for loop that points at the integer itself, right? The starting point, which is going to be denoted by I. I'll call this for I, in the nums array. So the length of nums, right? I'll just put length of n, right? This will start from 0. Now we want to pair the starting point with every other character, with every other integers, including itself, right? So here's how I'm going to do it. I'll just I'll take for I in this, right? So I will say uh for j now, right? J in now our starting point has to change this time around, right? Sorry, it's going to be range, right? Range of this, the length of this. So range here. Now our starting point has to change, because when you look at this, right, in the first iteration we started from this point, right? The starting point is 1, but in the second iteration we no longer start with 1, we start with 2, right? Sorry, I'm talking about this part here. In the first iteration, right, we started with 1, and then 2, and then we'll go 3, 3, 4, and 5. But every time we start a new with a new pointer, or let me just say with a new position, we no longer start from the beginning, we start from that particular point, right? So we are going to start from I is going to change every time. So our starting point is going to be from 2, which is the value of I at that point. So we are going to start with I, and then all the way to the last item in the array, which is going to be the length of n, right? So here, that is the only mistake I did, which was an oversight. So this way, we will only pair, we will only create every possible pair. So instead of me to just put range length of nums, I'll just start from I here, right? I'll just start from I, and this will, correct everything. I'll go over it again and explain what this code does, but let me just run it again. Now you can see this has passed the test cases. So I'll submit this and see what the answer is. Why didn't it show here? Anyways, it was a very good answer. So let me just go ahead, and it should have shown the submission on this side, but it's showing it here, which is really weird. Anyways, okay, that's good. Oh, I think it was my fault. Okay, so I'll go to description. When I submit, it should change it here, right? Okay, yes. You see, it was better before. Now it has changed. Hey, what's going on? I like this one. This one was 87. Anyway, so let me go back to the explanation and explain this properly, so that it is easy to understand. um I'll start with, first of all, we are given an array of integers, right? An array of integers, and we want to find out the maximum XOR value, right? XOR is basically exclusive OR, which is a bitwise operator in Python. You can use a bitwise operator. I don't know if a bitwise operator, so because I'm using Python, I'm just going to stick with the bitwise operator in Python, right? We want to find the maximum XOR value between two strong pairs. Now we can form, we need to understand first of all what a strong pair is, and also we need to understand how to determine or how to find a strong pair. First of all, a strong pair is such that the pair actually, satisfies this condition. The absolute value between those two pairs is going to be less or equal to the minimum between those two, right? The absolute value of the difference, sorry, between those two pairs. Now, sorry, let me just close this quickly. It's distracting. So now, uh, after determining the if the pair is actually a strong pair, then we can now go ahead and find the maximum XOR value, right? So here's what I'll do. First of all, a brute force solution, right, is to go ahead and create every possible pair with within this array. The question says you can pick you can pick the same integer twice to form a pair, which means an integer has to form a pair with every other integer, including itself, in the array. So one way to do this is to first of all, let me come here. So I'm just going to paste this number here again. So we have nums here, right? So one way to create a pair with every other value, including the integer itself, right? So is to create an outer loop, and then an inner loop starting from that integer all the way to the end of the array, right? So let me just show you what I meant by that. First of all, this is our brute force solution. So we are going to start an outer loop, right? The loop is going to, for I in range, right, range, the length of this array, right? So this nums here. Now we know I is going to start from 0, right? And as long as this loop continues and nothing stops it from continuing, we will go from 0, 1, 2, sorry, 2, 3, and then 4, right? So that's going to be our value, right? So I is going to be 0, 1, 2, 3, and 4. So meaning an integer at I is going to be 0, right? Is going to point at 1, and nums. So if I do something like this, if I run this loop and I do nums at I, right? By the time this loop runs, or by the time this loop is done running, we would have printed every number or every integer in this nums array, right? So because nums at I is going to take nums at 0, which is 1, nums at 1, which is 2, nums at 2, which is 3, and so on, right? But we want to create a pair, right? We want to create a pair. So how do we create the pair and also include the number itself? So one way to do that is to create the pair this way. So I'm just going to remove this first. First of all, just take this out, right? So it's to have an inner loop. We know we can get the first characters, the first integers with this first loop. So how do we get the second character? The second integers, we are going to use a second loop. I'll call this J, right? That's just an iterator. And this is going to be range, right? Range of, len of nums. Now there is an issue with this, but I just purposely left this way. Now this second loop here will do similar stuff, right? It will still start from 0, right? J is going to be 0 at some point. J is going to increase to 1, 2, and so on, right? All the way to the length of nums minus 1. All right. So let me, why did I, oh, I'll just remove this I from, okay, good. So my J is here, right? Now, so meaning if I want to create a pair, I could just do this, right? I could just say nums nums at I, right? Nums at I, and then nums nums at j, right? This will, in the first iteration, right, this will go this way. So I'll just start from nums at I is going to be 1, right? And then the inner loop will start. Until this loop is done running, we can't continue with this outer loop, right? This inner loop has to finish first, then we move back to the top. So we run this inner loop and do the necessary operations. So it's going to be, again, j at first is going to be 1, and then it will run again, and we'll have 1 and then 2, 1 and 3, right? 1 and 4, and so on, right? Until we reach 1 at 1 and 5, right? Where this loop will stop running. We'll now go back to the top again and start from I, increase I by 1, which is going to be at this position here. We'll have 2, right? We'll start from 2 now. Now, the issue here is that we want to continue with 2 and, 2 and 2, 2, and then every subsequent integer in the array, right? So here's what is going to happen in this case, right? You see the way I put this loop here, right? It's just going to do this. It's just going to take, range, right? Range of, for I in range length of nums. So j is going to be equal to 0 again. J is going to be equal to 0. And what number do we have at 0? It's going to be 1, which is wrong. We've already done this pair already, right? 1 and 2 is still the same as 2 and 1, right? This is also the same. So we don't need to start again from j being equal to 0, right? We have to start from the value, from the current value of I, right? So here, instead of putting length of nums directly, we need to have our own starting point, which is going to be equal to I. That way, we are just going to start with 2 and 2, then continue with the rest, right? So this way we'll be able to create a a valid pair, right? Or a correct pair, if in other words. So here, let me just demonstrate this in code quickly. I'll come here and so I'll use my playground. So I'll type nums is going to be equal to 1. I think I have it on my, so that's nums. So let's first of all loop and try to create these pairs. I'll run, okay, so for I in range, the length of nums, right? And then I'll do the same thing again for j in range. I mean, I and j can be anything, you can call them anything. So but I just prefer using I and j. So in length of nums, right? In length of nums. And then let me just print those pairs for you to see what's happening. So I'll just use print I'll print them as a tuple, right? So print nums at I, and then nums at j. Okay, so this loop is quite long. Let me just reduce this so that otherwise we'll have to see a very longer. So here's what we have. I'll just increase this. You can see we have our starting value will always start from so our starting value is on the left, right? Our starting value is on the left, and it will go from 1 all the way to 5, right? And it will repeat for every item in the array. But this is not correct. This is not what we want. We want it such that there is no repetition. You can see here we have 2 and 1, right? 2 and 1 and 1 and 2. They are all the same. 2 and 1 and 1 and 2 are all the same pair. So here's what we are going to do. Instead of starting the inner loop from 0, we'll start from I, right? And this solves 99.99% of our problems, right? So here you can see uh, you can see we have a much more accurate pair here. So we have 1 and 1, 1 and 2, 1 and 3, 1 and 4, and 1 and 5. Then we already have 1 and 2 already. So we now need to start from 2 and 2, 2 and 3, and so on. So the pairs here are actually correct. Now, we've found out a way to get this pair. So the next thing to do is to find a strong pair, right? We want to know which pair amongst all of these is actually a strong pair. So how do we do that? Well, first of all, we need to know the condition that makes a pair strong, right? And that condition is such that the absolute value of their difference has to be less or equal to the minimum between the two. So if if the absolute value of the difference between num I and, you know what, okay, I don't know, let me just keep typing it. Num I minus nums at j, right, the integer at this point, if the absolute value is of their difference is less or equal to the minimum between the two, right? I'll just take this minimum, let me copy this, between these two, right? If the absolute value is less or equal to the minimum between these two, then we know it's a strong pair. So first of all, we found out how to, we looked for a way to find a pair, and then we'll then move forward to looking for a strong pair amongst those pair we found. So here is what we'll do. So we'll just print this. When I run this, you'll see, oh, this becomes even, so all of these are strong pairs, right? All of these are strong pairs. If you go ahead and find the absolute value of the difference between each one of these, the result will reduce, right? The result will return true, because if you do 4 minus 4, let's just take 4 minus 4 for instance, the absolute value of 4 minus 4 is 0, and 0 is less or equal to the minimum between 4 and 4. The minimum between 4 and 4 is 4, right? So the minimum value is going to be 4, and so on. That will work for every other value here, right? Now, when we find the absolute value here, right, when we find the absolute value in this case, when we satisfy this, when a pair satisfies this solution, we will then go ahead and find their XOR value, right? So I'll just print, let me just do the calculation here. So I'll just put this here. Instead of printing it directly, I'll just print it this way. So you can see we have 0, which is the XOR value between 1 and 1, and 1 and 2, 1 and 3, and so on. So every other pair will return a certain value, right? So this is going to be 0, 1, 2 for the maximum value, and the maximum value here is 7, right? The maximum value here is 7. So how do we compute that? So I'll first of all put a maximum outside, the maximum I want to return at the end of the day, right? So I'll say max XOR, which is going to start with 0. We'll just set the maximum at 0 for now, and when we find the XOR value here, right, we'll compare it with the maximum we had previously. So I'll say current, I'll call this current maximum, right? Current maximum is going to be this operation here, and our maximum is just going to be, max XOR is going to be equal to the maximum between the maximum itself and the current maximum, right? So this way, we can then go ahead and return the maximum at the end of this. So I'll just say this is not a function, so I can just print this max XOR here, right? So you can see we have our maximum as 7, which is actually correct, right? Now um so this works fine, but there is a catch here, right? We know, in a case where we have, uh this is the first implementation, so we need to optimize this because every item is being checked here, right? We are looping from the first character and matching it with every other integers in the array, and then we are doing the same over and over again. But what if a condition here is not satisfied, right, at this point? So let me see, which example can I use now? Let me just check which one of these. So we have here. So we have here. I'll just go ahead and use this one. So let's run this again. Now this is 7, right? But the point here is that this will compute for every other value in the array, right? So let me show you what I meant by that. I will just print so if the absolute value between these two, right, I and j, is less than the minimum between the pair, then we want to calculate this, right? But let's just check, when this condition is not satisfied, right? So else, just print just print this, right? Just print the pair. So I'm just going to put it here. I'll just remove this here. I'm not calculating. So I'll print the pair that don't satisfy, the pair that doesn't satisfy this condition. So you can see we have 525, 530, 665, and so on, right? So the reason why this optimization is needed is because we know every other value, once we find a pair that doesn't satisfy, we just need to stop going through to the end, right? Because we know every other one will not satisfy this condition. And this works because this array is sorted, right? We know if we had if we do 5 minus 25, right, the answer will be 20. Or let's start with 5 minus 6. 5 minus 6 is going to be 1, right? The 1 is less or equal to the minimum here, which is 5. Now when we come to 25, right, and we found when we calculate the difference between 5 and 25, we'll get 20, right? The absolute value of 20 is 20. So when we compare it with the minimum between those two, 20 is bigger than the minimum, which is 5, right? So we know every other value will also satisfy, will not also satisfy the condition, because I mean, if the array is sorted, it means the array is starting from small to big, right? Small to big items. So we want to exit the loop early, right? At least the inner loop, we want to exit it early and not bother looking for every other pair that would probably be strong or not, right? So what we need to do here is to actually sort nums. Just make sure that it is sorted, right? Sort, and then we can just come here and find every, if this condition is true, right, every value that satisfies this condition, every pair that satisfies this condition, then we can go ahead and find the maximum XOR value. Otherwise we exit this loop, right? So we just break out of it. We just break out of this loop, and it will take us less time to run even, right? So it will be faster. Let me just print the maximum XOR here. So this will be equal to 7, right? So we will exit the loop early instead of going to find every other pair in the array, right? So yeah, that's just all we needed to do to solve this question. And what else am I missing? Maximum XOR. Yeah, we just need to sort the array exit the loop early, because we know every other value is not going to satisfy this condition, so there's no point continue looping. And this doesn't really change the time complexity of this question. I mean, the sorting algorithm is going to take um, n o of n log n, right? O of you know n log n, sorry, n log n, right? This is going to take o of n log n, and you know at this point here, right, the time complexity is is going to be it's going to be, because we have an inner loop, right? So this is still going to be equal to, what is this? This is going to be equal to, so we have an inner loop. It would have been O of n, but we have an outer loop which is O of n, and another inner loop again. So this is going to be O of n squared, right? It's going to be a quadratic time complexity. O of n, maybe let's just put the squared like this, O of n squared like this, right? So it's not the best solution per se, right, compared to the first way we did it, but this check here is going to help us exit the inner loop early, right? We are not going to continue checking for every possible pair. We'll just exit the loop earlier than earlier than we would have normally exited. So let me just copy this solution again and paste it as my optimized version, and I'll push it to leads code. So maximum XOR subsum contains duplicate. What was the okay? Yeah, maximum XOR. So here is the new implementation, and yeah, this actually works just fine, which is awesome. Okay, so let's move on to the next question. The next question is the longest substring without repetition, right? And I started this yesterday. Again, there was a little bit of oversight, as to what exactly has to happen at every point. So let me just come here, right? Hey, Michael. Michael is in the chat. All right, let me. All right, so the next question is, longest substring without repeating characters. Okay, so this question is actually very interesting, and it involves, tracking of unique characters in a string, right? In order to form a substring of, unique characters or unique letters. Um, okay, so in this string here we have ABC, ABC again, and BB, right? We can see that the output here is going to be 3, right? Because ABC was the longest we've gone through the string without any repetition. I mean, if we look at this, right, ABC, right, and then A, right, since we found a repetition, we could have said, okay, let's stop from there, let's stop that, and start from B again. So we'll go from B, C, and then A, right, and then there's again another B here, so we stop and we start from here, C, A, B, we stop again, and so on. So I mean, this is actually a very, I won't say, yeah, it was difficult for me anyway. So I mean, this is the third time I'm attempting this question. Even though I actually read some things on it, I didn't quite understand what what's it, I mean, looking at this question, you kind of have an idea of what to do, right? We know we have to keep track of every unique characters in the string, but then again, we also need to know, you know, how to track the position at which there was a duplicate, right? Or there was an occurrence of a unique character we'd already seen before. So, um, let me. So here was my, my solution yesterday. But I'll just go ahead and and try to explain this again for the third time. Trying to understand this question very well. So I'll copy this and just paste it here. Right, I'll use this string because I mean it's a good one. So, um, okay. Uh, Here's what we need to do. For this string, right? We want to find the longest we'll go through this string, right? From the first character all the way to a certain point without any duplicates, right? Looking at this, sorry, hold on. Sorry, I had you know house stuff. Okay, so we want to. Where was I? Let me start over again. Code copy as PNG. Okay. So want to go. The question is basically, for us to. The problem is just for us to go through the string from a starting point all the way to a point where there is a duplicate, right? So we'll go P W S R, and then up to this point here, right? Then there is a duplicate. So we'll calculate how many unique characters we've seen so far before the duplicate occurred, right? So this is going to be 4. We've seen 4 items. Now, how do we continue counting, right? Because now we've seen 4, right? And the duplicate occurred at this point. Do we continue from where we found the duplicate towards the end of the string, or we continue from a different point? And the answer would be to continue from a different point where the duplicate one less than the point where the duplicate occurred, right? So we are going to start from W again, right? So it's going to look like this from this point all the way here, and then from this point all the way to where there's a duplicate which is at S here, right? We have to stop you know 1 before s, so that we start from this point here again all the way to this point here, and we're at the end of the string. Now if you look at this, right, the longest we would have gone without, so this would have stopped here, so this will be 1 2 3 4 and then 5. So the longest we went through this string without seeing a duplicate is 5 steps, right? And you know, which is basically what the question is asking us to do, right? So how do we calculate this? How do we find this duplicate? Well, one way to do this, right, is to always have a point where there was a unique occurrence, right? Because as you can see, right, we this at this point here we marked it as a unique occurrence starting point, right? A unique string starting point. Or let me just put it that way. So at this point too, right, you can see P is no longer part of this window here, right? This P here is no longer part of this new window that we created up to this point. And then when we found another duplicate, right, which is S, right, increasing this window, we remove s from the window, right, and then we continue with the rest of the string like this. So this is how we can find the longest string without repetition. So we need to have a point where there was a unique occurrence, and then move the right pointer, let's just call it a right pointer, all the way through the string until we found another duplicate, and then we'll have to move past that point again, right? So um here's how we'll do this. So first of all, we have a loop, right? A loop that runs through the string. We just need one loop in this case. We don't need even two loops. We don't need nested loop to do this. And then we'll need a point where there was a unique occurrence. So I'll call this a left, right? This will be my left. Left is going to be equal to 0, which is a point at which there was a unique occurrence. Now we'll have a right pointer, right, that runs through the entire string, right, that goes through the entire string from start to end. So every time we loop through this string and there is a unique item or a unique character seen for the first time, we need to create a map for it, right, for every unique character. So p is going to be at 0, and then after adding this to the map, we need to calculate how many characters we've seen so far that are unique between the starting point, which is the left point where we saw an occurrence of a unique element, all the way to where right is in the current iteration. So right is obviously going to loop through the entire string, right, but left is going to move based on the point where we see a unique item. So here's what we are going to do. So p is going to be equal to 0, and then w is our next occurrence, right? Next occurrence of a unique item is going to be equal to 1, and every time we have to calculate the current maximum. So how do we calculate the current maximum? The current maximum is going to basically be, I'll just put current is going to be equal to the right pointer minus the left, right? The difference between those two is going to give us everything within that window, right? So right minus left, and since we started counting from 0, right, we need to add 1 to this to make it correct. So here is what we are going to do. So in the first iteration, right, our arrow is going to be equal to 0, our right pointer is going to be equal to 0. So we'll do 0 minus 0, right? Left is going to be 0 at this point, plus 1, right, so that it actually counts as 1, because 0 minus 0 is actually the window at which we found a substring with unique characters, right? But since we are counting in a human form, we need to add 1 to it to make it correct. So this means we've seen 1 item so far, and then we will do that for every other item in the string until we find a a duplicate, right? So here's what we are going to do. We are going to move the right pointer towards the left, right? I'll not repeat this again, but let me just do it this way. So I'll just WS, S is going to be at position 2, and at this point, the when we calculate the maximum, right, the current maximum is going to be equal to 3. Is going to be equal to 3, and then we'll have R, right? R will point at what? R will point at 3, and then we see P again, right? Now there is a P where R. Okay, can I move this out? I can move this out and just, I want to erase everything here. Right, so let me erase. Okay, everything has been erased. Okay, so I'll just move this back here. Right, when you visualize this, right, so here's what we are doing. We have the left and the right pointer here, and every time I'll just put my right pointer here, I'll put it here like this, and then every time we iterate through, right, through this string, we move the right pointer towards the right. We always need to update our map, right, until the point where we found a duplicate. So at this point here, there is already a P in the map, right, and R is at P. So what do we do in this case? Well, like I said, our unique occurrence is going to be such that we have our left pointer, our unique string, sorry, our string of unique elements or unique character is going to be such that our left pointer starts from the point of unique item. But since the left pointer is already here, and the unique item in this, and we've already found a duplicate at the position where R is right now, we need to move our left pointer towards this side here, and then update the value of the occurrence right here. We'll have to update this value here. This will be at position 4, right? This will be at position 4. Let's say 0, 1, 2, 3, and then 4, right? So this will be position 4. Now we've updated our string. Now we'll have a string that will look this way, right? It's going to look WSR, sorry, it's going to look WSRP, right? We removed the previous P from it. We updated our map, which is what we did here, right? We updated our map to the current position at which we found P. And then every time we do that, right, we also need to calculate the maximum at those points. So how do we calculate this maximum? Yeah, so here's what we are going to do. Again, we'll do the position at R, right? R is at 4 minus, now we moved L to this point, right? We move L to this point. L is going to be 1, then we'll do plus 1, and this will still be equal to 4. Now if you count every character we have in this string, it's going to be equal to 4, minus this P. This P is not part, so it's going to be 1, 2, 3, and then 4. Our previous maximum was 5, so we don't need to update the maximum at this point. We keep our maximum as 5, right? Or was it not 5? 0, 1, 2, 3. Okay, it was 4. Sorry, why did I write this 5 here? I don't know. So yeah, that's about it for this. Then after calculating, we have 4 as our current maximum, and since it's not bigger than the previous maximum we found, we don't update the maximum, and we continue moving. Right now we move R to this point, which is T, right? And there is no duplicate at this point, so we'll update the maximum again. We'll update the maximum again. At this point, the maximum will be 5 because R here is going to be 1, 2, 3, 4, 5. Oh, 6. So it was the value of R I wrote before. So R is going to be 6. L is 1 minus 1 plus 1, right? Sorry, it's going to be 0, 1, 2, 3, 4, 5. sorry, 5 instead of. So now we have a new maximum. We'll update our maximum with the value here, and then we'll continue moving, right? Now we'll move R here, right? R is going to be, now at S, and we already have S in our map here, right? So what do we do at this point? Well, again, we need to replace the value of X here, obviously. But before we replace it, we want to update our, you know, um our left pointer, right, to move past the last occurrence of S in the string to create a new unique string. So we have to move S all the way to this point here, right? We don't want to have S in this window anymore. The window is going to be like this. So when you visualize this, we are starting from this point all the way here, and then we are going from here, right, all the way to this point, because S, we don't want to repeat the same characters in a window, right? So we need to stop at this point here and then move from here to include every other remaining character. So when R is at this point, we have to move the left pointer to this point here. Now, how do we move the left pointer to the point? We just need to get the value of, of the index of the last occurrence of S in our map, which is going to be 2, and then we add 1 to it, which is going to be 3. When you count again, you will find out that 3 is at this position, R is at 3, and we move R here, right? So that's how you do, and you calculate the maximum between those two, right? And and so on. But there is a catch here, right? What if we've already moved R, we moved left to this point here, right? And in the current window, will be something like this. R R S R P T S A, right? So this will be our final window of unique characters in the string. But what if we found, let's say at this point here we had an R. Where should I put this R again? Let's say we had a mm, I want to give it, because there is a catch, right? What if the item we are looking at, right? The unique item in this window had, let's say we had, okay, so let's say we find a W here, right? A W at this point, and let's remove this. So we're going this way, right? We're going, now we started, L is at this point, right? L is at this point, and we go all the way up to this point here, right? And then we see a W, but we know already that in our map, right, when we only add items to the map when it's not in that map. So we need to update the occurrence of this item here, right? We need to update this to the value of W. W will be 0 1 2 3 4 5 6 7 8. So we need to change this to 8, right? Let me remove the count. We need to change this to 8, right? Because now we found another character here that is that was previously added to the map. But then what do we do in this case? Do we move L towards this point or not? Well, the reason why we don't even need to move L, right? Let's say we had W and W here, right? And we updated this to 8, right? Which means if we found a duplicate, we need to move the item towards that point, at least one after that point, right? We have to move it all the way to this point here. So if we had an item in the map and and it's not in the current window, but it was added previously from a different window, we need to update that value and always check, right, if the current position of L, right, of this left pointer is actually larger than, where it appeared, right, where we updated the value. If it's larger than it, right, if it's larger or equal to it, then we have to move, you know the left pointer to this point here. I'm not what's the best best example for this case. So let me use this PW. Yes, let me use this string and try and explain that, because it's, I tried it out and it was actually very useful to know that something like that could happen. So um let's say we had okay, my string here, so I'll change this to a blue color. So we have our map here, right, of unique items or unique occurrences. So I have P is going to be equal to 0, and the maximum at this point is going to be 1. So I have my left here, my right here, right? And I'll start moving the right. I'll move the right towards the right. The left has to be here, right? And then I found the W, right? So when I find the W, I'll update my map to 1, and then move this again towards the right. Oh my god, these are the wrong place. So I'll move my map towards here, right? Now at this point here, there is a duplicate, right? There's a duplicate, and the previous value of this one was 1. So we have to move the left pointer towards this point to start a unique string, right? Meaning we've excluded every other value, right, from this string. Now imagine we had a P here. This is the case. We had another P at this point here, and the value of P here is 0, right? We know we'll move, we'll always move the left pointer past the previous occurrence, right? So let me just keep it this way. We'll update this W to 2, right? This is going to be 2 because we found it at index 2, and then L is going to be here. The string is going to still have 2 items long, right? Because when you do L minus R plus 1, the value is still going to be equal to 2 as the previous maximum, right? So now when we move the right pointer towards this side, towards the right here, I'll move it towards the right, we have WK, right? And then E, and now P, right? P was previously 4, right? P was previously 0. So what do we do at this point? We need to update P, right? We need to update P to 4. And imagine we had more characters like S, right? Let me just put PES, right? Now, when P is at this point, when R is at this point and we updated R to 4, right? What do we do to K? What do we do to our left pointer? Do we move our left pointer, right? Sorry. Do we move our left pointer towards this side, right, ignoring every other possible occurrences, or we only move our left pointer when it is necessary, right? Because we move the left pointer based on the value of P, right, where it previously occurred, right? It previously occurred at position 0, right? And we take that value and add 1 to it to move it forward. But if we do that in this case here, let me just bring this back to 1. P would have been 0 previously, right? We found it at position 0, and we know we always move an item. We always move the left pointer past the previous occurrence, 1 more than the previous occurrence, right? But in this case, the previous occurrence is now less than the position where the left pointer is currently, right? Do we then move the left pointer one past the previous occurrence, or we just forget about it and just continue looping and update the value of p in the string. And it's obvious that it's the second option that is actually correct, because we don't want to move the left pointer to the back again, right? We don't want to move it towards this point here. We only want to move it when it is convenient, which means when the left pointer is actually at a position where we can move the left pointer forward and not backward, right? So that's the case where we need to keep the pointer moving, right? The left pointer moving. So if p is less than the current position, I mean, if the current duplicate we found, right, its previous occurrence is less than the point where our left pointer is currently, then we don't need to increase our left pointer again. We don't need to update the value of our left pointer, right? Otherwise, we'll find the left pointer moving back to this point here, right? We don't want that. So we only want to move the left pointer forward. Yes. So that's the only case where we need to, introduce some form of optimization, right? So I'll go ahead and code this again. So um I've done 1 hour already. Okay, no problem, no problem. So okay, right. So let me go ahead and do this, right? I'll just come to this point here. I started the question somewhere here. So here's what I'm going to do. Right. So I already have, some implementation on ground. And so here's the comment I added. So this will keep track of my unique characters, right, so far in the string. And this is the maximum length of, this is the length of the longest unique substring that we create, or a substring of unique characters. And the left is just the left pointer that will continue moving, right? Now the loop is going to go from, beginning to the end of the items in this. Is it yeah, in the string, right? So the right pointer, right? If there is an item already, if there's a duplicate in if there is a duplicate, right, which means if the current item we are seeing at the position where the right pointer is already in the map, right, then we have to move the left pointer by one. But we only have to move this if also, and if the left pointer, only if the left pointer is actually, we don't want to move it back, right? Only if the left pointer is superior or equal to that value there. So I'll just take unique character map and r, right? So only if this is true. Oh, sorry. Unique character s at, yeah. So at this point, it's only, okay. So I'll just say, let me add a comment here. Check if, okay, let me say if there is a, okay, there is a duplicate, right? No. So if s at right, if character character is a duplicate, is a duplicate, and the last occurrence, right, is less than, I'll just say last occurrence index, sorry, occurrence, okay, occurrence index is less than, right, less than where the left pointer is less than left, right, is less than left, then increase this, right? So which is what this condition is saying here. If we have a duplicate value, right, and the last occurrence of that duplicate value, which is the index of that value, is less than the left pointer, then we now need to move the left pointer forward, right? Otherwise, if it's not, hold on, what am I saying? Yeah, it has to be less than it, right, for it to move forward. And then we will need to update our dictionary at every point, calculate the current maximum, right, plus 1, like I said, and then find the maximum at this point here. Okay, so hold on. Wait, let me not mistake myself. So left, the point at which left occurred, right? So if we had 0 here and we have a duplicate here which is already in the map, right? Oh, sorry, the value has to be superior to the left. So left has to be less or equal to the unique character, so that we need to move left forward. Otherwise, left will just move back again. Okay, so that was a little mistake in code. So I'll just copy this again and run it in the terminal. I mean in lit code to see if it works. And here, run. Yeah, you can see the test case now passed, right? And which is awesome. So I'll just submit this. Yeah, and it works. It works just fine. Okay, so I'll push this to GitHub. Sorry, so let me see my previous submissions, right? So yeah, it took me a day to figure this out, or 13 hours, right? So yeah, that's good. Let's move on to the next question. Do I still have time? Yes, I do. I kind of have some time. I have about 5 minutes left, I think. So let me come to this point here. I'll just explain this quickly. I'm not sure I'm going to write the code for this, but let me try my best to explain. Now I can erase everything on this window. Bam. So we no longer have anything. Okay, so we have this question, repeated DNA sequence, right? The DNA sequence is composed of a series of nucleotide, abbreviated as ACGT, right? For example, we have ACGT. We have this example here. It's a DNA sequence. When studying DNA, it is useful to identify repeated sequences within the DNA. Given a string S that represents a DNA sequence, return all 10 characters long or 10 letters 10 letter long sequences substring, okay, that occur more than once in a DNA molecule. You may return the answer in any order. So we have this string, and then this is a repeated sequence, right, that is 10 characters long, right? This is a sequence. First of all, we need to find the first sequence, right? The first sequence is going to be such that let's say we have DNA, sorry, for example, okay, it's a DNA sequence. So it could be a sequence of any characters, right? It could be A, C, A. So far as those 10 items repeat themselves throughout the string, right? We can return it, right? So let's take this example here. I'm just going to copy this string and use this for my explanation. So we have this, right? Now our sequence has to be 10 letters, 10 letters long, right? So let me just bring this here again. Okay, so this is a DNA sequence we have here, and we want 10 you know, which color should I use? I should use this one. We want 10 items, right? 10 how they called? Um okay, so 10 letters, right? 10 letters that repeat themselves throughout the string. And how do we do that? How do we keep track of which item is, you know, which 10 sequence has been repeated? First of all, we need to first of all take the first 10, right? So we'll create a window like this. So we'll go from this point. So let me count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So we want to do this, right? We want to do this all the way to this point here, right? So that's 10, and we want this to repeat itself throughout the string, right? So how do we check that again? Well, if we're looking at 10 item at a time, right, we need to make sure that we look properly, right? So we'll go like this from here all the way to this point, right? Is this a valid sequence? Is it the same as this other one here, right? This is not a valid sequence, right? So this is not the same as this first sequence that we found here. So we need to check again from this point all the way to this point here. From this point here all the way, we have to check 10 at a time, right? We have to check 10 at a time, and we'll do this all the way throughout the string. And at some point, right, we'll have a repeated sequence. We'll have a sequence that we've seen before, right, by looking at these items this way. So this is a sliding window problem, right? Because every character we create, like every 10 items represent a window. Our window is going to be 10 characters long, and we need to look within that window to find a repetition. So if this is our first window, right, if this is our first window and we have a c a like 5 A's and 5 C's, then we want our next window, right, to also have the same thing, right? So this has 5A, but it's not in the same order, right? It's not A and then C, right? It's a different order, right? So this is going to start from A and ends with A, and this is not the same as this. But since it's not the same, we can't just say it's not a repeated sequence, right? It could be a sequence on its own. So let's keep it that way. We'll keep track of that as well. We'll keep track of every sequence until we find a sequence that is repeated, right, in the window. So basically, when we move from this point to this is a sequence on its own, right? It's going to look like this. We'll have 5A, right? Oh, we'll have 4A, 5C's, right? And then 1A here. This is one sequence on its own. The first sequence we had was 5A and 5C's, right? So this is another sequence, but we need to keep going, right? We might find a 4A again, a 4A, 5C, and then 1A again sequence, right? That is also a sequence on its own, but we just need to see the one that repeats, right? So at every point, each sequence has to be repeated. Okay, sorry, I'm back again. Um, so I mean, we are going to find, um, every possible. This is a sequence, right? 4A, 5C, 1A. So we need to find out which one repeats itself, right? So when we loop through, right, when we create every substring, this window has to be 10. It doesn't have to, shrink or increase. So we need to, look for every 10 items. So this is going to be, um, you know, A. So this is going to be 5A, 5C in the first iteration. Then we'll have 4A, 5C, 1A, right? And then we'll have 3As, 3As. So it's going to be 3A, 5Cs, all the way to 2A, and so on until we find a repetition. There will be a point where we now the window will be at this point, right? So it will be at this point here, from here all the way to this point here, right? Which means we'll have five A's and five C's, and we've seen before, from the start, that we had five A's and five C, right? So we'll return this string. So every time we need to have like a, you know um how do I put this, we need to have a placeholder, right, of each 10 sequence, right, 10 letter sequence. And every time we loop, we add those sequence to a particular data structure. It could be a set, it could be a dictionary, but I'm not really sure yet. But I think we can do that, and we can keep track of each one of these, right? We can keep track of them, and uh, we can keep track of each one of them. So every time we see um, a particular sequence of DNA strands, a particular sequence like this, we add that to the uh, to wherever we want to store them temporarily, and we keep checking if this sequence has been seen before, right? If it has been seen before, then we know there is a repetition. Otherwise, we continue counting, we continue creating the sequence, and until we reach the end of the string here. Yeah, this is going to take, I don't know, uh it's going to take a single loop to do this, right? We just need to loop all the way to the 10th item, and we know in every loop, right, we are looking for 10 item each, right? So we are going to look from this point to this point, from this point to this point, and so on. Yeah, so that's how we will solve this question. I think I'm running late now. I have to go quickly, but let me push this to GitHub so that you can have the latest. So git add. Oh my god. I don't know. Git add, git commit, right, dash m. I'll call this what I oh, there was a commit I made yesterday. Okay. Oh, all right. Let me just type it out again. longest longest sub substring dash no dash repeat. I'll just put r. Where is it? Repeat, yeah, r. And I'll just put plus, max XOR strong XOR SR again, because I did those two, right? Or why am I putting plus here? I'll just put like, like this, yeah. So, and I'll push this to get to push origin main. Okay, so this has been pushed. You can have the code in the description.